All right, let's talk a little bit about this Project 6 report. Now, what's going to make for a good report? Now, I have to admit that I actually kind of screwed up. I wanted to give you more to do than this in Project 6, but I accidentally gave you an old one. If you look at it, it says spring 2019, but it'll do. It's fine. You've got plenty to work on. What this says is, hey, you need to do an introductory paragraph, and then this discussion on the regression, and then a summary paragraph. So in some ways, this is actually really good because it doesn't give you a step-by-step thing, and hey, we're just about through the course. But let's look at really what we mean. Well, okay, so we need an intro, so you better have one, right? It's being graded. So introductory paragraph, and probably in this intro, you want to talk about the basic question of predicting volume of these cherry trees. Okay, so of cherry trees from diameter and height. Okay, and what we want to do is, in this intro, we want to choose a model. Okay, and we're going to choose that model based on p-values of slopes and adjusted r-squared for model fit. Now again, adjusted r-squared is really part of the modeling portion, and the p-value of the slopes of the variables we pick is really about the statistical nature and dependency of these things. We don't want to pick variables that have no dependency. I mean, why throw in a variable whose slope ought to be 0 because we get a big p-value? And but on the other hand, why just start throwing things, more and more variables and so forth in there if they don't really change the adjusted r-squared? I mean, fewer variables is better typically, and and you could try to talk a little bit about that. Fewer variables, okay, because of that thing, that bias variance trade-off. Okay, again, fewer variables is going to reduce the bias. Okay, but it's going to then have a bigger variance, and so you're trying to balance those two ideas. I can toss in so many variables, also in the form of like r squared. Well, be careful with the r, d squared, I guess. I was thinking radius r, but d squared for diameter. Or height, I could have height squared and height cubed and so forth. If I throw enough of those things at it, I will fit my data perfectly. Okay, so the variance from the model will basically be zero. In other words, I can hit every single data point. But what would that mean? It would mean the bias, it would be biased toward my particular data. If I go find another cherry tree, it could be very, very off. And so I don't want to bias it because I just took a sample of cherry trees, yet I'm trying to find something that models all cherry trees. So, it might be nice to try to talk about that bias variance trade-off, because that's what's involved in this project. And, so we want to model it. We need to worry about slopes and their p-values. We need to worry about the adjusted R-squared for the model fit. We need to think about this bias variance trade-off, which, another way to look at it is, we'll try to reduce the number of variables, but also keeping as high a adjusted R-squared as we can get. Okay, so, introduction, and then, other aspects of trees, like in my other video, I mentioned things like trees might look a lot like cylinders, but they might not, and so we're just not sure what we might get. Then it just has this open thing about the regression. Well, what I picture you probably ought to do is you probably want to look at a model suggestion. Okay, and maybe one of those model suggestions is, the volume is, some beta 1 times the diameter plus beta 2 times the height plus alpha. Now, if you do something like that, V equals, beta 1 D plus beta 2 H plus alpha, if you write that, and you never tell me that D is diameter and H is height and V is volume, well, you're not complete. You haven't defined, sure, you may say, well, Dillery, you must be an idiot if you don't realize D is diameter. Well, I am an idiot. Just ask my wife, Sure, you need to tell your audience what the heck you're dealing with here, and they may miss it if you don't. And so there's a model suggestion. Okay, well, what do I need to tell you about that model suggestion? Well, I probably need to tell you the result, and it'd be nice to maybe just do a screenshot of the result of the linear estimation command, right? And you show those slopes and they're well labeled, right? If you don't have them well labeled, then how do I know? And somewhere in there, either inside of there or you tell me, you could use your template and so forth. You tell me a p-value. You tell me, for each of those slopes, and you tell me an adjusted R-squared. So I need to have that information, and it might be nice to have it inside here, but if you just show me the 5 lines of the linear estimation and then tell me what those are, the p-value and adjusted R-squared, that may be okay as well. But to me, probably be easier just to do that with my template and just have them well labeled and shown right there in a screenshot, and then talk about them in the text. Okay, well, that's model suggestion 1. Model suggestion 2, you'll get that same information. You'll be able to compare the number of variables. Here were 2 variables. This model suggestion, it may still be 2 variables, but that might be your D squared H. So, that's still 2 variables, but it's treated a little bit differently. And in this first case, up here, I can't really show you a plot very well because it's two independent variables. Independent in the sense of explanatory, not in the sense of statistically independent. But here, if I do a beta, plus an alpha is my volume. Here, because that is a single column of data, I could actually plot, that column of data with the volume and show you a nice plot. But again, I could show you the len-s command. In this case, I could show you plot. Now, other plots that might be good just in general might be a plot somewhere in all this, maybe even before you really get started. You could just look at a plot of, volume and diameter. You could also look at a plot of volume and height, because those might show you some information. I mean, if volume and diameter look like that, I might really say, oh, that does look like I ought to have a d squared somewhere. Maybe not like that d squared, but it looks kind of like a parabola. It looks like a d squared. If I see something like that with height, I could say, oh yeah, height's very important, and we better have a height in there somewhere, somehow. But on the other hand, if height looked like that, we would probably say, we don't think height's going to be important, but let's run everything to see. And and what I suggest is you suggest 3 or 4. 4 is probably better than 3, but 3 or 4 models. And you get these results for each. And then you want to go through and make your suggested model and very important why. Okay, and certainly some of the things are going to be these p-values for slopes and adjusted r-squareds as far as model fit. Those are going to be very important in your why. But also, you get into that bias variance trade-off and, number of variables that you're using or how you're using that number of variables. So again, here I'm still using 2 variables in one sense because I've got a D and an H, but I'm only using one column. Okay, so I'm only using one column, which is different than using 2 columns here. Or I could use all the columns, and that might be one of your suggested models, is to use all the columns, and so you want to go through that kind of a logic. You want to take that time with each of the models, and then truly compare and contrast what might be good or bad about each of those models. That is the point of this exercise. And then finally, remember your summary, not just here. Here is sort of a summary in your choice, but also it mentions what the heck you learned. Kind of a reflection. Okay, remember to toss that in at the end, and that's the type of thing I think you want to do for this. So again, that intro, try to hit those points. Your model suggestions. I would go with 4. And, there are more. I mean, heck, you can go with 6 or 8, I think. But I think that would be overkill. But I want you to look at, more than one and truly show me you've thought about what is good and what is bad in each of these models. What seems to work pretty well, what seems to not, or they might all look pretty good. They might all have about the same adjusted R squared. They might all have very nice p-values on the slopes, very small p-values. So you're saying, oh yeah, this is all very important. And so they in that way they all may look about the same. Well, then what else might you look at? And that could be number of variables, number of columns. Again, there's variables and there's columns, and pretty much my guess is all your answers are going to have the two basic variables of diameter and height. Maybe not. Again, in the other video, I thought, well, maybe d and d squared might work. That would only be one variable, but again, two columns, because d is one column, d squared is another column. And columns are very much like variables. So when it comes to the bias variance trade-off, because I could have a single variable like d, but again, if I just keep adding powers of diameter, so d squared, d cubed, d to the fourth, and so forth, well, I can get a perfectly fitting model that will have an r squared, not an adjusted r squared necessarily, but an r squared of 1. Okay, it'll fit perfectly, but it'll be highly, highly biased. So, you got to be careful. Variable can be used in two different ways. Really, when we're talking about the bias variance trade-off, that sense of variable is really the number of columns you're using. And so here, this is one column, and up here this is two columns, and so in that sense, I'm kind of using more variables in the sense of columns and predictors in this first suggestion that I mentioned there than I am in the second suggestion here. So okay, so that is kind of how you ought to be thinking about structuring this project. And if you do not go through multiple models and then you do not compare and contrast them for their strengths and weaknesses, and then what do you like best and why, you really have not addressed this project. Okay.